Imagine sitting in your Cambridge IGCSE Physics exam. The clock is ticking, the pressure is on, and you write down what you think is a perfect answer. Let's stress test it and see if it holds up.
You write down area equals 20 centimeters times 10 millimeters, giving you 200. It looks so simple, right? But boom, the examiner gives you 0 marks. Absolutely nothing. This one tiny mixed unit mistake destroys your entire calculation instantly. It's going to cost you crucial grade boundary marks right out of the gate before you even finish reading the question.
So why does this happen even to super prepared students? Well, it's because ordinary revision totally ignores these fatal mark scheme errors. If you're just memorizing formulas, but you're missing units, rounding way too early, giving vague explanations, or using the completely wrong variables, you are leaving yourself wide open to dropping some really easy points, especially on those tricky practical questions.
To guarantee top marks and completely dodge those 0-mark traps, you need to apply this 4-step unit consistency framework to literally every single calculation. Step 1, identify the concept. 2, pull your evidence and data. 3, apply your scientific reasoning. And 4, lock it all in with precise examiner wording. Let me show you exactly how this plays out.
Okay, it all starts with recognizing the basic international SI units. We're talking about meters for length, kilograms for mass, and seconds for time. Using these same base units means we can easily compare the size of our variables and keep our calculations solid across all kinds of equations. You've absolutely got to lock these symbols in your head.
But what happens when we start combining those basic units? Well, you get what we call a derived unit. Take speed, for example. It's the number of meters traveled in each second, so meters per second. The rule here is absolute, guys. If your distance is in meters and your time is in seconds, your derived speed must strictly be in meters per second. If you try mixing in kilometers per hour here, that is a guaranteed 0 marks. Now, in just a moment, I'm going to show you the exact examiner clue regarding area and volume that changes the answer completely. But first, you need the framework we just discussed to make that clue totally obvious. Seriously, keep watching, because missing this upcoming conversion trick will absolutely guarantee lost marks on the hardest exam papers. Leaving this explainer now leaves you totally exposed.
Section 1. Interactive Speed Run Challenge. Spot the error. Let's crank up the stakes.
All right, here's the challenge. What is fatally wrong with calculating area as 20 centimeters multiplied by 10 millimeters? I want you to pause the explainer right now. Seriously, hit pause and predict the specific error in this calculation before the examiner deducts your marks. Okay, did you catch it? Here is the fix. Your units have to match. They absolutely must be consistent. You have to convert that 10 millimeters into 1 centimeter before you do any multiplying. You simply cannot multiply centimeters by millimeters and expect to get a valid square centimeter area. It just doesn't work that way. Let's build this into a much harder challenge. I want you to spot the lethal error in this area conversion table before time runs out. Notice the first line. It tells us to divide centimeters by 100 to get meters. Makes sense, right? Perfectly fine. But look really closely at that second line for area.
Is converting square centimeters to square meters really just dividing by 100? Think about it. This is the exact mathematical trap that catches students out on those higher-tier Cambridge papers. If you fall for this, your subsequent calculations for density or pressure will instantly shatter.
So here is the crucial point. This is the examiner-style correction you need. Converting area actually requires dividing by 10,000. And volume? If you're going from cubic centimeters to cubic meters, you have to divide by 1 million. 1 million, because there are exactly 1 million cubic centimeters in 1 cubic meter. Forgetting this massive conversion factor instantly tanks your final answer. It literally takes your perfectly memorized physics concept and feeds it absolute garbage data. Section 2. Top Band Examiner Correction. Let's fix this properly. Compare these two approaches. The flawed answer just mashes mismatched units together to get 200. It's a total mess. But the top band answer? It correctly substitutes values with consistent units, 20 centimeters times 1 centimeter, and it states the final derived unit clearly as 20 centimeters squared. Doing it this way secures all your method and accuracy marks entirely.
To make sure you always land in that top band, use this practical checklist on every single paper. 1. Use correct terminology. 2. Substitute consistent values. 3. State your final derived units. And 4. Check for reasonableness. Does the number actually make sense? Ensuring your scientific reasoning perfectly aligns with the required examiner wording is a real game changer.
But wait, this creates a massive unresolved problem. We've mastered basic static units, sure, but how do you apply these to complex density and uncertainty practicals? Mastering static unit conversions is a great quick win, but it leaves you dangerously exposed for your upcoming data analysis and practical investigations where multiple shifting units start colliding. To rebuild your practical skills stronger and close this curiosity gap, you absolutely must click on our next explainer immediately, the Physics 0625 Last 7 Days Revision Map. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE, to excel in your Cambridge examinations. You've mastered static units, but what happens when density shifts your entire equation? Click over right now, and let's find out.